Hello everyone, my name is Mihaela Ștefan. I am a professional services engineer at Infinet Wireless. Thank you very much for taking the time to join our webinar. Today we are going to discuss about link redundancy using our Infinet Wireless devices. Let's begin by introducing the concept of redundancy. When designing a network, we have to first consider the strictly necessary resources in order to ensure a proper operation at the required parameters. However, you cannot rely on the minimum needed resources, so backup resources must be included. Basically, redundancy refers to the extra resources and measures that need to be implemented in order to design a reliable network. With respect to the type of resources that we are talking about, we can have different types of redundancy. First, there is the equipment redundancy, where more devices with the same or similar configuration are co-located so that they can replace each other in case of failure. Next, in order to ensure redundancy in terms of infrastructure, you need to provide local connectivity backup links, as well as different transmission paths for both the cabled and the wireless segments of your network. Another important aspect that needs to be considered is to set up a backup for the power supply source. Next, a bit more difficult redundancy implementation is to find and rent backup installation sites when necessary and if possible. And last, I want to highlight that staff redundancy is as important as the equipment redundancy and the infrastructure redundancy. Ensuring the proper number of people to maintain the network will automatically increase the reliability of your network. As you can see, redundancy is a complex aspect that needs to be regarded from many perspectives. For a stable and robust network, you need to consider implementing it for all the reviewed resources and subsystems. Now let's check the scenarios where you need to seriously consider implementing redundancy. First, we have the remote sites, which can take a very long time and effort to get to. In some cases, the location is only accessible by helicopter, so only the fuel used to get there might be more expensive than a single backup link. Therefore, redundancy must be implemented since the beginning. Another example is when the procedure of getting to the site is very complicated. For example, the approval procedure might take several hours or a day. So during this time, the connection will remain down unless a backup is installed. Redundancy is very important for the enterprise last mile connectivity as well, or for the mining industry, where a lot of money can be lost in the event of a link downtime. So the backup links are usually mandatory in this case. The redundancy scenario can be complemented with the configuration of link aggregation in order to increase the capacity when a high capacity is required for your link. Additionally, for the wireless connectivity, full duplex implementations are available using the same redundancy setup in order to overcome interference or if higher capacities are needed. We'll now review some typical redundancy schemes. Let's begin with the 1+1 configuration, where just one regular link is installed with no possibility to implement redundancy. In the picture, you can see an XG link providing gigabit connectivity. In case that this link fails, there will be a communication outage until the fault is handled, so there is no redundancy. Then we have the 1+1 configuration, which is the most typical redundancy setup, and it involves having two parallel wireless links between the same points, but only one of these links is active at a given moment. In other words, you have a main link and a backup link, and both links can be configured using the same operating frequency. The backup link is not operational for as long as the main link is up, and it becomes active only if the primary link is interrupted somehow. We will explain the failover mechanism later during our webinar, so you will understand more details a bit later. The 2+0 configuration is also comprised of two parallel links, but this time both links are operational at the same time. This means that besides redundancy, you can implement mechanisms like link aggregation to effectively increase the link capacity. You can also achieve a full duplex communication by forcing all the uplink data to go through only one link and all the downlink data to go through the other link. But you will need, of course, different frequency channels for each link in this configuration, since they are both active in the same time. Now let's review a more complex scenario by adding the ring redundancy configuration. Let's imagine you have an enterprise that has 4 main locations or buildings. The local area network branches of every location must be interconnected using redundancy. Suppose that the link between LAN 1 and LAN 2 has the highest capacity requirement of 1 gigabit per second. For it, you can add a link in parallel to ensure availability in case that the main link fails. Additionally, all the local area networks are interconnected in a ring topology, as you can see in the picture. Now, suppose that the link between LAN 2 and LAN 3 is out of service. You will still have a connection between the 2 local area networks using the longer path along the ring through LAN 4 and LAN 1. Also, the main link that requires the highest capacity has an increased fault protection as it benefits of redundancy through both the ring and through the R5000 link in parallel. This is a realistic redundancy implementation, but the scenarios are very vast and can be adapted to the needs of each project. What is very important to keep in mind when introducing redundancy is that by providing backup connections, we create loops in the network. Redundancy means therefore loops, so unless we use a proper configuration method, we will be facing with the broadcast storms that cause unavailability instead of increasing the availability, which was our initial main scope. Moving forward, we can introduce a classification of the redundancy configuration methods. Manual and automatic configuration are the main options when implementing redundancy. From now on, we will consider redundancy in case of using our Infinet units. The automatic redundancy implementation is divided therefore into external or internal configuration with respect to the devices on which you perform the configuration. So if you configure redundancy on third-party equipment, we talk about the external redundancy. If you configure it, however, on the Infinet devices, we refer to the internal redundancy implementation. Our devices offer multiple choices to implement redundancy. We have implemented standard protocols like STP or OSPF, which include redundancy as part of their functionality. On the other hand, our developers designed proprietary protocols and features that offer superior redundancy configurations for the wireless links, taking into account as well the radio link state in real time. We will discuss in more detail all these aspects. Let's now discuss each method in detail, and we begin with the manual configuration. As you can see in the picture, we have a main radio link comprised of XG devices and a backup radio link using Infilink 2x2 devices. What I want to mention here is that with the R5000 units, you can back up literally anything. It doesn't matter if the main link is wired, wireless, or if it uses devices from another manufacturer. The picture shows a 1+1 redundancy configuration, so only one radio link is active at a time. Currently, the main link having the higher capacity is active and the R5000 link is disabled. Let's now suppose that the main link becomes unavailable. Since there is no automatic redundancy configuration available, a person has to manually perform the necessary actions from a monitoring system or by connecting to the units directly through the web interface or CLI. More precisely, someone has to manually activate the R5000 link so that it becomes active, as you can see in the picture. The manual configuration is easy, but it has the disadvantage that the downtime is high compared to the case when the radio links are enabled or disabled automatically. Basically, there will be an outage until someone detects that the main link is unavailable and performs the manual configuration. Let's move forward to the external redundancy configuration method. As I mentioned, when we say external configuration, we refer to configurations performed on third-party equipment, like, for example, the switches that are not manufactured by Infinet. This type of configuration is suitable mainly for the XG, XG1000 and the Quanta 5 family that are designed for data transmission at high speeds, so they function as bridges without concentrating on packet processing and on higher layer protocols. In this case, you can enable, for example, STP on the switches, and it will automatically block one of the ports on the switch, leaving only one path active at a time. The disadvantage in this case is that the external devices do not take into consideration the radio link conditions. Also, STP does not see the differences in capacity for the two links. So no matter if they are wired or wireless, it can block the link with higher capacity when both are available. Now we will discuss the standard protocols that are available for implementing redundancy. We begin with STP, RIP, and OSPF, which all include redundancy capabilities. What is important for you to know is that you can implement these protocols only for the Infilink 2x2, Infiman 2x2, and Infimax devices. We already talked about STP earlier. I want to mention that it is a layer 2 protocol that has as main scope to avoid broadcast storms in the network segments that are connected in a loop or a ring. To achieve this, it blocks as many ports as necessary in order to avoid having several paths between any two nodes. When the active path becomes unavailable, it will automatically switch to a different physical path. The disadvantage, as mentioned, is that it does not consider the link capacity. So be careful when implementing STP for links of different speeds. Next, the layer 3 routing protocols, RIP and OSPF, will take into account the speed of the link and adjust to topology changes in real time in order to choose the best path with the shortest time to reach the destination. The disadvantage when using layer 3 routing protocols for wireless connections is that it does not take into account the real-time radio conditions. So even if the quality of a high capacity link degrades, it will still be chosen to route the packets because only the maximum theoretical speed of the link is taken into account. This is why it became necessary to develop a proprietary routing protocol that takes into account the radio link status in real time for wireless connections. Next, Virtual Router Redundancy Protocol, or VRRP, is another open standard protocol that was especially created to offer redundancy. It operates at layer 3 and it is based on the idea that multiple routers are grouped so that they form a single virtual logical router that will act as the default gateway for all the local devices. VRRP can be configured on our R5000 devices. So using the setup in the picture, we can configure VRRP on slave 1 and slave 2 using only one virtual IP address. On the PC, we have to configure this virtual common IP address as the gateway. VRRP will elect one of the slave 1 or slave 2 devices as master router, and it will decide which is the best path to route the packets from the PC towards the core network. So VRRP can ensure redundancy and a loop-free network, but keep in mind that it is a layer 3 protocol, while STP that provides similar functionalities is a layer 2 protocol. Let's now move on to the proprietary protocols that are specifically designed for the products of Infinet. Here I will introduce you to Mint, our proprietary protocol used by the Infilink 2x2, Infiman 2x2, and Infimax devices. Mint is actually a collection of protocols and technologies that were especially designed to fit with the requirements of a wireless data transmission. Since our webinar focuses on redundancy and packet forwarding, I will detail only the Mint capabilities that are related to our current subject. So Mint routes packets hop by hop using the best path in real time, similar to a classical routing protocol, but it uses MAC addresses instead of IP addresses. Therefore, we say that it operates between layer 2 and layer 3. The Mint routing table contains all the routes available to reach every destination, and the destination devices are identified by their MAC addresses, and each path has a Mint cost associated. Looking at our picture, you can see that the nodes are interconnected using multiple paths for redundancy. For example, to go from node J to node F, there are highlighted 3 different paths in red, green, and blue, but actually there are many other routes available. This is very good for redundancy, but it contains many loops that might cause severe broadcast storms unless a specific protocol for avoiding loops is used. Mint is particularly good at avoiding loops since it is acting as a typical routing protocol by keeping record of all paths but only choosing the best one for packet delivery. Mint also avoids the transmission of broadcast packets even for service information since it uses a special multicast transmission. One last very important mention is that Mint knows the radio link status in real time. So even if a higher capacity link degrades considerably, Mint will be aware and choose the alternative path. This is not valid for STP, OSPF, and other standard protocols that only consider the maximum theoretical capacity of the links and do not consider the real-time speed. A useful configuration for redundancy is the one where we introduce Infimax devices instead of normal switches. This way you can create a single Mint area and configure link aggregation on the Infimax devices in order to sum the capacity of the 2 parallel links and use them both when available. This way you have also an increase in capacity added to the availability increase. This is a typical 2+0 configuration, as you might recognize, and in case that one of the link fails, the other link will automatically be used for transmitting the data. What is very important to mention is that even if Mint is loop-free, inside the Mint area, we still have connectivity with the external network through several paths, so loops will appear in this setup. Therefore, you have to either remove from the switch group on the Infimax one of the Ethernet ports that are going towards the wireless units, or you have to enable STP on the Infimax devices. Moving forward, another scenario is the implementation of a full duplex transmission. By default, our devices operate in half duplex mode, but by creating a single Mint area, you can add an extra cost, having a high value on the required interfaces. For example, you must add an extra cost on the RF interface of master 1 in order to force the uplink traffic to go through the master to slave 2 path. Similarly, a high cost must be added on the RF interface of slave 2 in order to force the downlink traffic to go through the master 1 slave 1 link. Next, I want to present a setup where the backup link is not using Mint, so it can be XG devices, Quanta 5 fiber connections, or any other third-party layer 2 connection. You can still create a single Mint area and benefit of redundancy with link aggregation. By using the Infimax devices, optimal operation is ensured even when the links provide different capacities. Infimax supports Mint, so it is aware of the bitrate on each link. This means that it will also take the link performance into account when computing the traffic path. You should also remember what we mentioned about the external network loops, so don't forget to enable STP or to remove one port from the switch group on the Infimax. So in our setup, in order to force the higher capacity link to be the main one, you have to also configure an extra Mint cost. Let's now review another fault-tolerant scenario. A CPE is installed on a moving vehicle. Along the moving path, there are several base stations installed. All the traffic of the base stations is aggregated towards the Infimax device using wired connections. Let's suppose that the cable between base station 1 and the Infimax is damaged and it cannot transmit any data. When the vehicle begins to move, its CPE will establish the connection with base station 1. At this point, no data reaches to the backbone because base station 1 is isolated. Even if the vehicle enters the coverage area of base station 2, it will not connect to it until it leaves the coverage area of base station 1, so it increases the unavailability time. However, if the global feature is activated on the CPE, it will only establish a radio link with the devices on which the global function is also enabled. So if the global function is enabled on the Infimax and on the CPE, while the base stations will provide a proxy feature between them, then all the base stations will inform the CPE that they have a connection with the Infimax. If the wired connection is damaged between base station 1 and the Infimax, base station 1 will not inform the CPE about the availability of the Infimax, so the CPE will not establish a radio link with base station 1. It will just wait until it enters the coverage area of base station 2 and immediately establish a link with it. The scenario is efficient when the coverage areas of the base stations overlap, so this means having a redundancy in coverage. Using this setup, you will increase the availability of your network. Next, let's review an important redundancy functionality of our Infilink 2x2 and Infiman 2x2 devices, the failover feature. This feature can be configured in a setup like the one in this picture with the two parallel radio links connected through two switches. The prerequisites are to configure PRF interfaces and to join them in order to create a single mint area. The same frequency can be used for both of the links because only one link will be operational at a given time. So this is a classical 1+0 scheme. The principle of operation is very simple. The Infinet Wireless device on which the failover feature is configured checks the availability of a specified MAC address. If this MAC address is available through both paths, then the operation of the backup channel is blocked. In our case, we have to enable failover only on the master 1 device. You can either opt for a manual configuration by specifying the MAC address of the slave 1 unit or for the automatic configuration. Both methods are very simple to configure, but if the costs of the two paths are equal, you must manually add an extra cost on the backup link. In our setup, you can add an extra cost on the master 1 slave 1 link so that the higher speed XG link is chosen as the main link, having the lower cost. So in our setup, master 1 sees the MAC address of the RF of slave 1 through both ways. Therefore, it blocks the link between master 1 and slave 1 since it has a higher mint cost. The RF port on master 1 is actually turned off and only the XG link is active when both links are operational. Next, if the main link becomes unavailable, master 1 will see the MAC address of slave 1 only through the backup R5000 link, so it will automatically switch the transmission to the backup link. The transition to the backup link is associated with a short-term idle period. If the main link becomes available, it will be automatically chosen to be the active link again since it has the lower mint cost. Please remember that XG does not support mint, but since we configured PRF interfaces on master 1 and slave 1 and joined them, the whole L2 connection is seen by mint as a pseudo radio connection. What I want to mention also is that when the main path is active, the RF interface of master 1 is completely off and slave 1 is just silent, waiting for commands from the master unit. As you can see, this is very easy to configure and very efficient. So it must be used in case of implementing redundancy. We have covered all the main subject of this webinar. You can find additional documentation about every protocol and feature that we reviewed in the documentation section of our website. Please also feel free to write us at academy@infinitewireless.com if you have suggestions, questions, or need help with your projects. At the end, I want to summarize the important aspects that you must keep in mind from our webinar. First, you must plan your network from the beginning to include redundancy for the different subsystems, even if it refers to infrastructure, equipment, power supply, or people resources. Next, when implementing redundancy for your infrastructure, you introduce loops in your network, so you must use an appropriate protocol or configuration in order to avoid the broadcast storms. External redundancy on third-party equipment is suitable for Quanta 5, XG, or XG1000 devices, since they are designed as network bridges and concentrate on transmission at high speeds, not on implementing upper layer protocols. Internal redundancy can be configured using our Infilink 2x2, Infiman 2x2, and Infimax devices in various scenarios according to the specific project, and by mixing different advanced protocols and features like Mint, Failover, the global feature, STP, OSPF, or VRRP, which are all protocols that we covered during our webinar. This brings us to the end of today's webinar. Now, if you have any questions, please feel free to ask them and I will answer them one by one. In the meantime, we'll just have a short break. Thank you. So far, I see only one question. The question is if can any other switch be used with link aggregation in the scenario with the R5000 units with Mint? Yes, if you already have switches that support link aggregation, you can configure link aggregation directly on your switches, and you do not require particularly Infimax devices if your switches already support link aggregation. We have another question. We are asked if for the scenario where one link is used for upload and the secondary link is used for downlink, this means that if more capacity is needed, we can apply this scenario. Yes, this scenario of a full duplex can be used to increase the capacity, and you separate the uplink transmission from the downlink transmission on a different path. But you are using both links at the same time, so you have an increasing capacity. It is the 2+0 configuration, okay? You can choose either link aggregation or full duplex in order to increase the capacity. The difference is that for link aggregation without full duplex, the uplink and downlink directions will take turns in transmission. I see there are no more questions. So thank you once again for your time, and I hope to see you again during our next webinar. Have a nice day, everybody.